So as I mentioned, I started at the end of the line, so there was always some extra pressure on me to show that, I belong there. And that's why I continued to do not only due diligence, but I went out of my way to do more than what I was asked for. And I think that's really what they noticed. They liked it. They let me know that how much they appreciated that. And that's how those awards kept coming.
Hello and welcome to another exciting episode of the Being an Engineer podcast. Today's guest is Dr. Mahantesh Hiremath, a veteran engineer, educator, and engineering leader whose career spans some of the most demanding environments imaginable: deep underground systems, offshore platforms, on-ground infrastructure, and space systems. He is former vice president at SC Solutions, now teaches mechanical and aerospace engineering at Santa Clara University, and served as the 140th president of ASME. Mahantesh, welcome to the Being an Engineer podcast.
Thank you for having me here, and great to be here.
Wonderful, wonderful. Well, we're excited to have you and your enormous background of diverse engineering experience. Can't wait to hear about some of your stories and the insights that you'll be able to share with the engineering community here. So before we do that, we're going to do a quick rapid fire Q&A with you. Just got a couple of questions here. Give whatever answer comes to mind quickly. No need to think long and hard about these ones. So the first one, are you ready?
Yes, sir.
Okay. Which engineer, living or dead, do you most admire?
Well, I would say Steve Wozniak, because he was the
Hmm.
one who sort of helped pioneer the development of Apple computers and really helped Steve Jobs, bring his ideas into fruition.
Great answer. He probably does not get enough credit, does he?
Oh, he sure doesn't, but he is one of the inductees of the Silicon Valley Engineering Hall of Fame, and that's how I know him.
Well, maybe one day we can have Woz on the show. That would be, what a treat that would
Oh,
be.
that would be fantastic. Yeah.
That would be. Yeah. Okay. I'll have to work on that one. All right. Next question. Physical notebook or digital notes?
Digital notes.
Okay. I'm with you there. Same. Constraints or freedom? What leads to better solutions?
Constraints, I would say.
Okay. And last one, if you weren't an engineer, what would you be doing instead?
Well, I would like to be a doctor.
Ah, interesting. Any particular area of medicine?
Two of my brothers are cardiologists, so I would have liked to follow them. Yeah.
Terrific. Well, that's a perfect segue into the next question. Now, as we get into the formal interview here, what made you decide to become an engineer versus a cardiologist?
Well, engineering is truly sort of in my DNA in the sense that my father served as the head of the mechanical engineering department of a state in India, and my brothers also pursued that field. So growing up surrounded by that mindset, so engineering was it was not less of a choice or more of a natural calling. And so what was left to me was to only decide which discipline of engineering to follow through.
And how did you decide on the discipline?
Well, again, it was my brothers had taken civil engineering, so I decided to follow through on civil engineering. So I became a civil structural engineer, just like my brothers.
It's amazing how much of our lives appear to be defined by our families, right? Decisions our families or perhaps close friends have made
Oh,
that,
oh
that trickle their way into ours.
I totally agree. I mean, Yes, and especially, in a close-knit family like ours, it was a natural choice to make.
Terrific. All right. Well, you have a very varied background in engineering. I mean, everything from deep underground, offshore, on ground, space environments, right? Infrastructure. What are some principles of engineering that have remained constant regardless of the application of engineering?
Well, if you see at the core of every environment, whether it is you're looking at deep underground environment or offshore or on ground and in space, it is the engineering mechanics that remains the same. And that engineering mechanics is grounded on the first principles of physics. So mastering those fundamentals really was my anchor, and it allowed me to seamlessly transition between very drastically changing environments and scenarios, and continuously grow up while enjoying the thrill of going from one industry to another.
How did that work for you, going from one pretty, different industry to another? Were those intentional decisions that you made, or did opportunities just kind of fall into your lap and you followed those opportunities?
Well, yes, certainly the opportunities came along, but at the same time, it also came down to taking some willingness to take some calculated risks. Because whenever I pivoted for a new industry, I essentially went back to the end of the line and trying to prove my credentials to do the job for which I was hired. And that means, I had to prove myself that I would be capable of taking up those responsibilities. But I was very fortunate in the sense that I was able to collaborate with some outstanding mentors, and who made that transition, helped me make that transition almost seamlessly. And looking back, I think having that beginner's mindset, it paid off in some sense. And I'm happy to report to you that I won outstanding service award at every company I worked for.
Amazing. Oh, okay. There are several things I'd love to dig into there. You talked about having mentors that helped you make those transitions successfully. What were some of the things that your mentors did to help you be successful?
Yeah, one of the things that a mentor can help a mentee is uh, understand what the mentee needs at a particular time. And for me, it was trying to understand what what principles of engineering mechanics are really key for that particular industry, and how I need to adapt to that. So I think that was the key that my mentors helped me understand. And at the same time, they were willing to spend time with me to go that extra distance in order to make me feel that I belong, and I can make that transition easily. So I think it helped a lot.
You talked about first principles a few minutes ago,
Yeah.
and that's a term that I feel like it gets thrown around quite a lot these days, and for good reason.
Yes.
But there might not be a lot of definition or concrete understanding around exactly what first principles really mean when it comes to engineering. How do you think about first principles?
As I mentioned, en- engineering starts with engineering mechanics. And engineering mechanics is rooted in really the first principles of physics. And so that's where, the terminology of first principles of physics is really the key for making. So physicists develop all the principles of physics, It is the engineers who use those principles to develop things, build things, and make life better for the community at large.
So these are things like F equals ma, right? And
Yes.
basic, yeah, thermodynamics
So
and fluid dynamics.
Newton developed F equal to ma, but we used F equal to ma to develop a lot of other utilities that humanity and community at large can utilize.
Yeah. You mentioned that you were able to be very accomplished in the different areas in which you worked, and even
Mhm.
won awards and recognitions at these different organizations and companies. What do you think allowed you to climb to that level? I would assume there were plenty of peers who were also considered for these awards, but you ended up winning some of them. What was it that you did that allowed you to be so successful?
So as I mentioned, I started at the end of the line, so there was always some extra pressure on me to show that I belong there, and that's why I continued to do not only due diligence, but I went out of my way to do more than what I was asked for, and my supervisors, my managers, they noticed that I really cared not only for the assignments that I was getting, but also I was looking for more than that, and I was delivering more than that they were asking for. And I think that's really what they noticed. They liked it. They let me know that how much they appreciated that, and that's how those awards kept coming.
Under promise and over deliver.
That's right. Well said.
Can you think of a time, an experience that you had that illustrates that principle of doing more than what was asked of you?
Yeah, sure. When I was working in the aerospace industry, we used to take our satellites out to our competitors, Lockheed and Martin, neighboring facility for acoustic testing. And when we had to first ship the satellite to their facility, set it up there in the acoustic chamber, run the test, and then ship it back to our facility. So normally that whole event would take, anywhere 3 days almost, if we were lucky. So on one of those days, we shipped the satellite, and then there was some trouble, and uh, the facility was not ready, or it was delayed. So I stayed overnight there and continued to work there until the test started. So I worked 36 hours straight without any break until the test
Oh my
was
goodness.
completed. And
Wow.
so that was the kind, and the satellite came, like 12 hours ahead of the delivery schedule. So every hour counts in the satellite delivery. So uh, the program director was very, very happy that we could bring the satellite ahead of schedule, and that was very much appreciated. So this was the kind of thing I thought that this was something that I could do, and if I could do, it's in the benefit of the company, and I ended up doing it.
That's amazing. Great story. Thank you for sharing that.
Uh-huh.
As we talk about going the extra mile, doing more than in what is expected of you, does it just come down to spending more time, or is that a myopic way of thinking about under promising and over delivering?
So I think when it comes to engineering, and especially you know engineering like required in space technology. So, when we launch a satellite, we can't bring it back to fix it. So we have to get things right first time and every time. So when we are working on something as complex as uh, you know, a, a satellite that weighs, 15,000 pounds, okay, then we had to do that due diligence, but at the same time the problem that arise, we had to also continuously be problem solving on the go. And that's why it was not just spending time per se, but it was also doing smart work so that you avoid repetitions, you avoid rework, and you continue to stay on cost, you continue to stay on schedule and also maintain the cost baseline.
Yeah. Let's pivot to another role
Mhm.
that you had, which is president
Mhm.
at ASME, large organization. Hopefully, all of our audience is well aware of who ASME is and how they serve the industry. But if not, can you talk a little bit about what is ASME
Yeah,
and what was your role there? What did you do during your time as president?
sure. So ASME, of course, stands for American Society of Mechanical Engineers, and it was the society that was set up back in 1885. So it has a long history, and ASME's codes and standards are, world renowned, and they are a stamp of authority that are used worldwide, actually. And volunteering for an organization for ASME's caliber teaches you invaluable art of really leading without formal authority. And in doing so, you are forced to make, you know, you're in a way forced to learn the finer art of, leadership, cultivating mutual respect, mutual trust, and also teamwork. And ASME has some 36 technical divisions where world renowned experts get together to develop, you know, good practices guidelines for emerging technologies. Then those could evolve into ASME's codes and standards. ASME is also an organization that can bring the right stakeholders like the government, industry, academia, national labs together to develop good practices guidelines for science and technology policy. So these are the kind of things that ASME does. And to get involved into an organization of that caliber gives you an opportunity to not only expand your network, get to know some of the world renowned experts in the process, but also practice your leadership skills in a non threatening environment. And if you do that, then you can always bring back those skill sets to your workplace and become a better leader. So for me, I started as a member of a local section, became a chair of the local section, then became a district leader, then became a congressional fellow, followed it up by becoming a member of the board of governors, and my last stop was becoming the president of ASME. This was the first time any Asian or Indian has become president of ASME in its 140 years of history.
Wow.
So it was a great journey for me, but it also proved that anybody, if I could do it, anybody could do it. And in a way, I credit ASME that the ASME gave me all those opportunities, and I couldn't be more grateful.
A question comes to mind as I'm listening to you speak. Now, you've talked about putting in the extra effort that probably equates to more hours at some point, but maybe not just more hours.
Yeah.
To what degree do you credit your success with going the extra mile versus being very intelligent? Now, you're probably a humble man, and you're not going to come off and say I'm smarter than everyone. But my guess is you're a fairly bright guy. Uh, uh, how do you think those two contributed to your success? Intelligence versus just hard work and persistence. Are they equal, or is one more important than the other?
Yeah, again, like you may have seen it on the baseball field also. There are many talented, individuals, but if you can't produce it at the key moment when your team needs a base hit or a home run, then it's all waste. So having uh, talent or having intelligence is one thing, but to put it to practice in order to help your organization, help your company develop products and services that really makes a difference. And if in case of say ASME, for example, after I became president, we really increased ASME's footprint worldwide. And for the first time, ASME's largest conference is now being held in the US and also in India now. So,
Hmm.
as a result of that, many participants from Japan, Australia, New Zealand, East Asia, Middle East, Singapore are able to participate and get their papers published more easily by participating in the same conference in India than coming all the way to the US and not getting those opportunities earlier.
What is one of the things that you're most proud of accomplishing during your time as president at ASME?
I think the biggest accomplishment would be, I would say, would be increasing ASME's footprint worldwide. And as I mentioned just now, getting ASME's largest conference moving and holding it overseas has really increased ASME's you know ASME's prominence in the area, in the Southeast Asia, Australia, New Zealand area, and Middle East. So that has certainly helped. The other thing that has also was happened during my tenure was that we established specialty groups uh, related to space technology and also robotics. And both of them have now evolved into full-fledged technical divisions. So
Hmm.
now ASME will have its world-renowned codes and standards related to robotics and space technology related journals also coming out for those two areas. So I would say those two are probably the biggest contributors during my tenure.
Terrific. What is one thing that you would like mechanical engineers to understand about ASME that perhaps they don't know about right now or don't fully appreciate?
Yeah, I think that's a very good question because just today, today was the first day of, spring quarter, and I was talking to my class and I was telling them how my career has evolved and how ASME has played a very key role. And I was encouraging the students to join the student section of ASME. And of course, I was more open to the idea that ASME is not the only engineering organization on the campus. They could join IEEE, ASCE, there are AIAA, there are other organizations. But so long as they participate in one of these societies, that will help them grow, that will help them expand their network, when they are looking for, say, students are looking for, always looking for summer internship. And all these organizations bring uh, speakers on the campuses. When the speakers come, they are normally, very high caliber speakers. They are the decision makers. So students are able to meet them, exchange resumes, and make the first contact with them, and to show interest that they would be wanting to work for their company as summer intern. So those are the kind of opportunities you get while as you become members of the society. The other thing is also, of course, you are able to attend the the seminars that are given by some of the very reputed speakers. So those are the opportunities that students get. And then I also, of course, shared how my own career evolved inside ASME, and I and that can happen to them also if they start even with the student section, the same progress they can also expect.
That's a great point that probably a lot of engineers don't think about much is the networking and the
Absolutely.
connections that come as a result of being a member of
And
ASME.
can you imagine, Aaron, that for an immigrant like myself, who had no idea, who had not even heard of what ASME is, to find a pairing and then evolve inside the organization, I want to
Yeah.
share everything about it with everyone and let them know that, hey, here is a career path for you, and you must take advantage of that.
Well, I hope that your words today will inspire everyone listening to this to go out, check out ASME
Huh?
and consider joining and think about what that can do for you and your career.
I hope to.
All right. Well, you have some experience as a congressional fellow
Yes.
or advising the House Committee on science and space and technology. What was that experience like? What did you learn about how engineering expertise, being an SME in the discipline of engineering, affects public policy?
Yeah. Aaron, coming from Silicon Valley as a technocrat with passion for current affairs, I truly did not know what to expect when I arrived on the Capitol Hill. But by the end of the year, you know, I returned with a profound respect for both the political leaders as well as their very dedicated staff that works for them. And that's because, we in Silicon Valley, we are techies. We work with a set of variables and some constraint, and we try to find an optimal solution to an engineering problem. On the other hand, on the Capitol Hill, the leaders are juggling with an overwhelming multitudes of variables and constraints, often striving to make an optimal decision that will offend least number of people. And I shared this with the chair of the committee during my exit interview, and he stood up and shook my hand and he said, "Mahantesh, that's a great line. I'm going to use it everywhere I go." That is the hardest.
Uh,
Optimization is the hardest engineering problem, and we solve it
wow.
more regularly than the engineers do. And indeed, that was the case. So, but at the same time, what was most encouraging, I find, is that on both sides of the aisle, they have truly have great respect for the scientists and the technocrats who come and give depositions, and so they revere them, they respect them. They may disagree with them, man. That is okay because they have to do it for the TV. But at the same time, personally, they are very respectful of them.
A little bit ago, you used the phrase leading without any real authority. I think that was in the context of ASME being the
Uh-huh.
president there. Can you expound about on that a little more? What does that mean, leading without authority?
So, when you are in a professional workplace, you have authority over people, so uh, you lay out the what is expected of them, and then your direct reports are supposed to deliver on that. On the other hand, when you are working for an organization for ASME, we still have some projects and programs that we need to deliver, and we have to deliver it as a team. And because this is a volunteer organization, you can do it only by creating a scenario where you can do that through respect, trust, and teamwork. And that's why I call it as leading without authority. And if you develop those habits in places like ASME, in an organization like ASME, and if you practice those, if you bring those back to your workplace, you find your work habits have changed completely, and your own colleagues and direct reports have so much more respect for you just because
Mm,
you know you are dealing with them on a different level now.
that's terrific. I love that. It resonates with me a lot. Is there a story that you can share that illustrates this principle of leading without authority and the impact that can have on people following you and the respect that they have for you and generally collaborating, working with others?
Sure. So when I was the chair of the local Santa Clara Valley section, one of the things that I did was arrange for um, seminars from some of the experts in my company. And I had a few colleagues who were really world renowned experts in their area, in thermal engineering, in orbital dynamics, and they have never been asked to do anything like that. And when I told them that, would you like to be ASME's guest speaker and come and give us a seminar on orbital dynamics, uh, or say thermal engineering, they were flattered, and they came, and we organized the event. And the last event that we organized was given by um, Failure Associates. If you know the company that did the famous deflate gate analysis for NFL, so four of their experts came and gave us a seminar for ASME, and we had 250 people attend that.
Wow.
Okay, and so it was like we had 50 people in attendance, and then 200 people worldwide on video conferencing. So it was again part that whole organization of that was done through my team at ASME, and it was all done by teamwork. One of them happened to be my direct reports. And so when we came back after the event, and a few weeks later, we were working on a very tight, you know, deadline, and we were really late on it. We were struggling. We were working late nights, trying to finish it, and yet I never lost my cool, or didn't show any extra stress, and continued to work through that, and we managed to somehow finish that work on time. At the
Mm.
end of that, my direct report came to me and told me, you know what, I learned a lot from you during this process. At ASME, you did the same thing with the same calmness, and you came here and you worked through that with the same, fluidity. and everything worked really well.
So what I'm hearing from you is that compassion and kindness are better motivators for performance than fear.
Oh, yeah, you can't make people work by fear. Yeah, that's the worst thing you can do. Everybody has talent, and everybody takes pride in their work. And the only way you can bring their best out of them is to make them feel great about what they do. And I think that's what I have done whenever I had opportunity to lead teams.
Is there a practical, what's the word I'm looking for? A tactic sounds too sterile somehow, but a practical tool or strategy that you've used to circumvent fear and use, like you said, help people feel good about what they're doing to bolster performance.
I think one thing you do as a leader is, there is always pressure coming from the top. As a leader, you have to be able to absorb that and only pass through what your team can handle.
Mm.
And at the same time, your team is going to tell you how much they can do under the under the resources that are available, under the time frame that they are being given. You have to have the courage to go back to the leadership to tell what can be delivered realistically, whether the leadership would like it or not, and do it in a way that the leadership will appreciate, you know, the forthrightness. Then the right decisions come about by doing this. But as a leader, you have to be able to protect your team, and as a leader, you have to be also able to be very candid with your superiors.
That's a great principle, being the buffer in between
Yeah,
your leadership and those
I
working
think
underneath you.
I think you earn a lot of respect by doing that. People see it actually, that you are under a lot of duress, but you are not passing it on to them.
For some reason, because of my engineer brain, the mental picture I have of this principle is the leader as a spring
Yeah.
in between the top and those working under you, and you might get compressed 6 inches by the top pressure, but maybe you only let 2 inches out on the bottom. You've got that spring buffer in there to compress and contract as needed.
So long as you don't crack, that is okay.
So
Yeah.
springs have a tremendous cycle time in their life, so hopefully,
Right.
yeah, right. Okay. Going back to your time at Capitol Hill,
Yes.
for engineers who might be listening to this thinking, I'd love to influence public policy
Yeah.
somehow. What's the path into doing that?
Yeah, I think that's a great question. And, I especially, where, where I am in Silicon Valley, where there's a lot of innovation coming around all the time. If people from Silicon Valley say take more interest, join societies like IEEE, AIAA, ASME, then all of these societies they send congressional fellows to work on the Capitol Hill. So that's certainly one of the options that you can get an opportunity to go and work on the Capitol Hill, actually participate in the writing legislation related to science and technology policy. And what a great feeling it is actually to participate in that whole process. Uh, it's a great feeling. The second thing is all of these societies also have technical committees that develop good practices guidelines. And those guidelines could come about as, uh, you know, technical guidelines for the community at large to use before any standards come up. So that is also another area where people can participate and certainly make um, their viewpoints known. So I think those are the two places where certainly, you can make a difference.
Great advice, great practical tips. Um, what are you most interested in these days? You've done a lot
Yeah.
in your career. What still excites you about the discipline of engineering?
So, you know, I feel I'm on the last lap of my engineering career, and if that's the case, then I always tell that my motto is aspire to inspire before you expire. So my motto is really,
You've got these great sayings.
so the motto really is to inspire every young mind to work in space technology and space exploration. I think the coming decade is going to be very, very exciting. We are going to go back to moon very soon. Already, Artemis 2 is getting ready to go around the moon and come back. So there is going to be a habitat on moon and Mars in the coming decade, and very, very exciting things are going to happen. So I'm telling my students that please, take advantage of all of that and be part of that. And when it comes to setting up habitat, it's not just that the engineers are required. The habitat requires everybody. What we do on the planet Earth needs to be done now on Moon and Mars. So geologists, scientists, everybody is required to be part of that whole development, and that's why I think it's going to be it's going to take a village to really build that habitat.
Yeah, right. What has been I've got just a couple more questions for you, and
Uh-huh.
then we'll wrap things up here. But second to the last
Yeah.
question is what has been one of the best decisions that you have made for your career? And then uh, on the opposite side, what has been one of the maybe worst or best learning experience decisions that you've made for your career?
Yeah. I think one of the best decisions that I made was I I would say, interesting. You say that one of the best decisions is to treat everyone equally and everyone equally well. I had a summer intern working for me while I was working on the high-rise building seismic analysis of high-rise buildings I was doing, and he graduated from Stanford and then joined the space company in Palo Alto. And he joined sometime in September, and it was about that time that my company was also going through you know, some low times. So I was looking around for a job. So uh, I sent my resume to this intern who had worked for me. That intern gave that resume to to his manager. Now the manager called me just because that intern had given the resume, and I thought I did reasonably well in the telephone interview. Then I didn't hear from the manager. A week went by, and every time the following week I was getting his voicemail. Finally, when I got him online, he said, "Yeah, I remember you, but don't call here. We don't work with concrete and steel." And I thought that was the end of my aerospace career. So, but the gentleman was so nice that, Ellen, you would be surprised. Following week, he called me back again and he said, "You know what? I was very rude to you. maybe you can do a few things for us. Why don't you come in for a personal interview? And I went in, and at the end of the day, I had the offer letter, and
Oh, wow.
so started my career in in space technology, and I became a lifelong follower of space technology forever. So
Amazing.
if any best decision I made was to treat my intern well during the time he spent with me, you know. Yeah,
That's wonderful.
yeah.
That's wonderful. Anything come to mind? And if not, that's fine too, about one of the worst decisions you've made for your career.
I think one of the worst decisions I made was probably, uh, I was working for Northrop Grumman at one time. I had a very, very good job. They liked me and all of that. And then I decided to quit and go back to Space Systems Loral. I think I think I disappointed a lot of people at, at my workplace, so I feel bad about that.
Hmm. Well, in the grand scheme of things, if that's one of the worst decisions, disappointing a few people at an old company, I guess that's not the end of the world.
Yeah, but my space was at my heart, so I decided to go
Yeah.
back.
Yep.
But yeah, so
Well, no one can fault you for that, following your
that's
passion.
right.
Yeah. Okay, well, let's see. Mahantesh, last question
Yeah.
for you. And really, really, this is a question for our audience, but it
Yes.
starts with you.
Yeah.
You've been very generous sharing your experiences and your insights, and we've all been richly fed by that. So thank you very much.
Uh-huh.
I I love being able to make
Yeah.
connections between different engineers, right? And bringing value, helping other people.
Yeah.
And so a question I've been asking at the ends of these interviews, which has gone really well,
Yeah.
actually. So I want to keep doing this is what's something that you're trying to learn or a person that you're trying to meet or something that you're looking for help with that perhaps one of the listeners of this episode might be able to help you with?
Yeah, if anybody has, you know, any unique ideas that they want to share with the senior class, then they are most welcome to get in touch with me, and I would be happy to arrange a talk with the senior class at Santa Clara University. That would be one thing. If anybody has something that they want to for engineering to do for betterment of humanity, then ASME Foundation is the best place to donate anything in terms of monetary donation. If that's what help, if that's what somebody is looking for.
Terrific. And for any of the audience members out there who are listening and are perhaps interested in taking you up on your offer to speak to the next generation of engineers
Mhm.
and probably somewhere near Santa Clara
Mhm.
University or contributing
Mhm.
to ASME, how can they get in touch with you?
I think the best place to get in touch with me is on the LinkedIn profile. My information is there, so they can find my both email as well as my phone number there.
Terrific. Okay, well, Mahantesh, thank you again so much for being a guest on the show today and sharing all of your wisdom and experience with us. Is there anything else that you'd like to discuss or cover before we finish up this episode?
So again, I know I'm very appreciative of this opportunity, and I commend you for doing this and continuing to do this and bringing professionals and helping your audience uh, learn from these things, and hopefully the young audience is learning from all of this and make some good career choices.
I hope so. That is the goal. Yeah. All right. Well, thank you again so much, Mahantesh, for being on the show
Thank you,
today.
and let me know if I could be of any help. I know I'm more than happy to get you some guest speakers or something if you need, let me know.
All right. Well, maybe we'll have a offline conversation about that.
Sure.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.